Hmm, a triangle cannot exist given this information or given this information. So, if it turns out that a triangle can exist in either one of these situations, then I'm going to say false, because this statement is claiming that both of these situations will result in zero triangles. So we'll see if that turns out to be true. Now, I see that they're talking about an angle and two sides, right? Capital A is an angle, lowercase a, lowercase b, those are both sides. Okay, so in other words, this is our side-side angle situation. It's the ambiguous case. So what I've taught you is whenever you're dealing with the ambiguous case, always start by drawing a horizontal line and put your angle on the left. Okay, so they're mentioning angle A, so the angle must go here. I always tell you to put a dotted line across from the angle. Think of it as a rope. And if this is angle A, then this will be side A. Okay, now I tell you to put the other side on the left. So the other side they're mentioning is side B. So I'll put that here. That means that this is angle B across from side B, and this is angle C. Well, they don't mention any C's, so I won't confuse the picture with them. So this is what we have so far. So let's look at the first situation. Angle A is less than 90 degrees. Okay, so this is acute. All right, this is some acute angle. Now A is less than B sine A. Okay, they're talking about the height. The way we check to see if you can make a triangle at all is by finding the height. And the way we always find the height is we do r sine theta. Okay, now when I say r, I'm thinking of, I'm picturing this as a radius that's rotating around point A. So when I talk about r sine theta, I'm talking about this side. So this would become b sine A. Okay, so b sine A, this is the height. So we're saying A is less than the height. Okay, so if this is less than the height, all right, in other words, if the rope is less than the height, then it will not reach the ground. All right, so that means no triangles. Zero triangles. All right, and so far that matches what the statement is saying. A triangle cannot exist in this situation. So far it's true. But to stay true, this other statement also has to be zero triangles. So let's draw again, but I'll switch to purple. Okay, same thing. All right, well, this time they say angle A is greater than or equal to 90 degrees. Okay, so that means the way I kind of have it drawn right now is no good. I have to make it bigger. So it's either going to be 90 degrees or obtuse. All right, but it can't be acute. So I'm just going to say not acute. And now I'm going to draw this. All right, so this is our angle A still, so this is still side A. We always put the other side here. The rest of it's still the same. Okay, so in this situation, Now A is less than or equal to B. Okay, so again, if A is less than or equal to B, then it won't reach. All right, if A is too short, it has to be longer than B in order to reach the ground. If it was exactly the length of B, it would just barely reach, but there wouldn't be anything left over to make a triangle. So the rope has to be longer than B in order to reach and form a triangle. So if it's less than B, it's too short, no triangle. So this is another situation with 0 triangles. So that's what it said. A triangle cannot exist in either of these situations. That is true.